Hi everyone, welcome to our event. This event is brought to you by Data Talks Club, which is a community of people who love data. We have weekly events, and this is a very special event. We have a workshop today, not the usual webinar. And yeah, you know everything you need to do. So we have a link with events. You of course have to subscribe to our YouTube. Not have to, but I recommend you to subscribe to our YouTube channel. You will not regret because workshops like the one we are going to have today, we will have a lot of them, and you don't want to miss them. And yeah, we have an amazing Slack community. And actually, yeah, I think I will just give the floor to you. So I will stop sharing my screen. And yeah, I'm really excited about what we are going to see today, because today we are going to talk about hands-on monitoring and 3 stages of monitoring. But yeah, the floor is yours. You will now tell us about all the stages and the materials you prepared for us.
Awesome. I'll share my screen and
Yes.
I'll start walking through. So I have some kind of intros in there.
Yeah, maybe can you make this the font size a bit larger?
Oh yeah.
So people like me with small screens can still see something.
How is that? Pretty good.
Yeah, that's good. Thank you.
I'm gonna wait a second for it to show up on stream, maybe just to make sure. But and you can see my screen, right? Okay, yeah. Stream's just behind. I see my screen. I think we're all good. All right, so we're gonna talk today about the 3 stages of data monitoring. Before we do that, though, we're just going to do some quick introductions and talk a little bit about some high-level concepts. But most of this is going to be us running code, and then we'll dive a little deeper into those concepts as we go. So I love learning by doing, and I like running code, and then changing code. Like if I was taking this workshop, taking what I'm seeing and then trying it with either my own data or messing around with it as we go. So in this workshop, we'll cover how to implement your own real-time data validation and monitoring systems from start to finish. And we're going to kind of talk about 3 different stages. Most of us have probably at least done the first stage, which is reactive. So we've probably seen something go wrong somewhere, and then we kind of have to manually go in and, analyze what's happening. And so we could visualize it, look at our data frames, depending on what we're doing. And then we find out an error somewhere. I'm sure if you've ever worked in data or you've ever done machine learning, you've probably had something like this before. And then the next stage is proactive. So we're going to talk about some ways to implement data quality validation as part of your data or ML pipelines. So hopefully that'll get rid of some of the errors that could come up. And then we'll talk about kind of a real-time end-to-end monitoring system or a monitoring technique to kind of look at data as it moves through your system. So you might have multiple stages in your pipeline. You might have a pre-processing stage for your data, and then you might be making predictions with a model. And we want to detect kind of and keep track of data through all those different points in our pipeline. We'll also kind of briefly discuss some important data and ML monitoring concepts. So if you're not new, or if you are new to ML monitoring, don't worry, we'll go through high level and kind of talk about some of the things we need to think about. So by the end of this workshop, my hope is you'll be able to implement data and AI observability into your own pipeline. And so the tools we're going to be working with, they have integrations for a lot of the common tools that are used in popular data stacks like Kafka, Airflow, Flight, etc. And the only things you'll need is you'll want a Google account to copy this Google Colab. So I think the link is in the live stream description. So if you want to go grab this, you can. Cool. Yep, I see it down there. And then the only other thing you'll want to do is create a free YLabs account. So you can just click the link again. I think that's in the description as well. And there's no card or anything required. I think you can just sign up, in a couple clicks using a Google account or sign up with your email. So again, hopefully this is just going to be a super friendly introduction and hands-on workshop that's an overview to data and ML monitoring. So again, I think I mentioned we're going to spend several minutes just on intros and high-level concepts, but then we're going to jump into the code pretty fast and start running things on our own. And just keep in mind, you can't learn everything in an hour or an hour and a half. So we're going to go into a lot of concepts, and maybe they're new to you. maybe it feels fast-paced or challenging. That's totally okay. It doesn't matter, your experience level. I think you'll hopefully learn something out of this workshop, whether you're new or a little bit experienced. Obviously, it's important to keep learning after the workshop. So I have some resources, and we can talk about resources afterwards. And then also in the chat, feel free to ask questions and answer questions. So I will try to look at it as I go, but I know I won't see everything, especially because there's quite a few people here already. So feel free to answer questions too. If someone else asks a question in there and you know the answer, feel free to chime in. And
there's already a question if there will be any focus on text embedding monitoring. So maybe you can tell us what kind of focus we will have today, what we will monitor.
We won't be talking about text embedding monitoring today. However, the tools we're using can be used for text and embedding monitoring. So we'll go through kind of somewhat of a simplistic pipeline in this case, but we can dive a little bit into the tools later as well, maybe after when we finish up the workbook. And we actually have some features around that coming out really soon as well in the YLogs tool. So I won't show an example today, but you'll be able to do that with the tools that we're going to use today. And thank you for the question. Feel free to keep asking them. So I'm just going to do a quick intro, a tiny bit about me. My name is Sage Elliott. I'm a technical evangelist at YLabs.ai. Previously, I've worked in computer vision, machine learning. I've taught at data science and web development boot camps. I also used to be a hardware engineer before I got into software development. There's often, or there can be quite a bit of overlap if you're working on hardware and then you need to program that hardware to do something. And that's actually how I got into machine learning in general. Was I was working in an IoT startup and we were manufacturing a really complicated part. And I thought I could use computer vision to do quality assurance on it. And it ended up working pretty well, which was pretty awesome. And in the hardware reliability engineering phase of my career, I actually used a lot of data monitoring. And I kind of wish that I had some of the tools that we're going to talk about today. It would have made my job a little bit easier versus kind of writing everything from scratch. And in that case, it was kind of on edge devices. It wasn't always streaming in. And we're going to talk a little bit about that today as well. And in general, I love making things with technologies. I also enjoy teaching and talking about tech. So you can stay connected with me on LinkedIn, Twitter, or in the Robust and Responsible AI Slack, which again, links to everything I think is in the description. So a little bit about you. I know there's a little bit of delay on the stream, but I always love hearing from the audience. Where are you watching this from? Why are you interested in data and ML monitoring? And are you already working in data, or are you learning right now? I know, Alexa, you have a lot of really cool content around learning as well, which maybe is a good moment for you to plug it if people don't know.
Yeah. Well, yes, I don't even know where to start. We have so much cool stuff. So start with our Slack. I'm wondering if I should make a poll. Maybe about the last one, if you're already working in data or learning, because today I learned that on YouTube you can actually create polls, and today I made one. I was asking about what do you use for signing up for our events. Maybe I can make another poll. So we will make a poll about the last one. So let me see how I can do this.
And yeah, I'm just if you get to this point of the stream and it's there's a little delay. So I might be quiet for a second, but I want to read the responses. See, someone's watching from Brazil, from Paris. So cool to see. This is one thing, like I was saying earlier, I miss in-person events, but one thing really cool about virtual events is being able to connect and, talk to people all over the world, which is pretty awesome. Someone said they do more like cloud DevOps, but they like to explore. Cool, I see the poll popped up. Someone said they're an ML engineer in India. They're interested in monitoring as they're making a transition from data scientist to ML engineer. Awesome. Watching from Switzerland. So cool. Definitely keep talking in the chat. And again, I think it's really fun to stay connected with each other. So I know you can do that in the Data Talks Club Slack or in the Robust and Responsible AI Slack. So I always recommend people when they go to an event to join whatever Slack they can from that event, because it's cool to stay connected and like reintroduce yourself in there.
And we will come back to the poll results, like, I don't know, in 5-10 minutes, right?
Okay, yeah, that'd be cool. And what was the results for the sign up again?
Yeah, mostly from Eventbrite. So even first Eventbrite, then Meetup, then others, and then LinkedIn. So LinkedIn is
Gotcha.
like least popular.
That's like what I've seen from my experience of running events. Like maybe a lot on Meetup as well. Meetup and Eventbrite, I think, depends on what you're doing. Awesome. Thank you everyone for responding. All right. So what is data monitoring? At a high level, data monitoring is used to hopefully proactively evaluate data to make sure that it's really in the format that we're expecting to perform the next task with it. So this could be in machine learning's case, right? Like there's pre-processing and there could be like the input part of it. So making sure that the data, when it's entered or coming in from a sensor. So again, like I've worked in computer vision a lot, so a lot of my analogies go back to computer vision. It's also very visual, so I think a lot of people understand it. So, you know, if we're collecting images from a camera that we want to run a machine learning model on, we could have a data quality problem from the start where, let's say we're in a factory floor and someone turned off the light, and so now the images are all dark. And if we don't have a monitor in place for that, we could just be running our model, and you know, depending on how it's set up, we might not have any alerts for days, right? If it's a factory where no one's in or no one's checking in that place. And I've seen something like this in real life, so I'm actually pulling from experience. so someone turned off a light that wasn't supposed to be off, and then, you know, this model is running and we're like, wow, cool, we haven't seen any anomalies in our manufacturing. And then it turned out that the light was off. So there's actually a data quality problem right at the beginning. So we'll talk about how to monitor for that. And then you have all the other stages, right? Like data can come in, you can transform it. So again, with images, you might be shrinking those down. You might be annotating them. You might be doing other transforms to it. And again, not just images, but this can happen with kind of any type of data. So during that pre-processing step, something could go awry there as well. And it may not be in the format that you're thinking it should be before you feed it to your ML model. So we have all these different kind of stages of what can be happening in the production environment. And then typically we want to be collecting some sort of telemetry from there, whether it's data or ML related. And then we want to do something with that telemetry, such as check for data quality issues. Like, is it in the format that we're expecting or within the range we're expecting? And then we'll also want to monitor things for other types of anomalies. So there's something called data drift, which we'll talk a little bit about in a second. So yeah, actually, let me just scroll down and we'll talk about some of the other ways that data can fail. So data quality, like I was expecting, or like I was saying, you know, there could be some big change that really just doesn't fall in the range or format that you're expecting anymore. You have something called data drift. So the most common version of that people think of, at least in the ML world, is something called feature drift. So again, drawing back to the experience in computer vision, we could say that if we have a model deployed and it's in the real world and it's looking outside and you're counting livestock with it, and your model was only trained on data in the summer. So let's say the grass was green, and so you're looking at cows in a pasture with green grass behind them. But now in the winter, there's snow on the ground. So instead of having green background, it's now white. So there's a distribution shift, in this case, of color values in an image, right? So like we would, our model was trained only with the green background, and now there's a white background. So it looks a lot different than the original training data set. So usually it's kind of like you have the shift of, you have a training data set with all these samples in there, and then you have new data coming in the real world, and it gets a little bit messy most of the time. So especially if you're in a non-static environment, which like a lot of computer vision applications are in. You also have a model drift, which we'll talk a little bit about later as well. And again, we're just doing a very high level introduction to these, and then we'll actually be running code to kind of look at these things, and we can go a little bit deeper during those sections. So model drift is when the data doesn't change coming in, but the model is no longer mapping to accurate prediction. So a good example of that is the housing market's changed quite a bit in the last several years, right? So if we had a model that we trained in 2019, and we are feeding it, let's say it's a super simple model and it's only looking at square footage of the house and like age of the house, right? Well, the data coming in hasn't changed at all. The square footage is still the same. You know, the age of the house is roughly the same, but now the prices being predicted from the model no longer really match the real world expectation. So that's something where our model, it, you know, was kind of trained on old data and is no longer mapping to the correct predictions that we'd be expecting. And another thing we'll often want to monitor for is if our model is biased. So if there's any way that our data can have some sort of bias towards some sort of feature. So if you're doing a financial model of some sort and you're making some sort of predictions on zip codes, that's usually very bad, right? Like you don't want to have any sort of data that ties someone into like where they live. And then just keep in, yep.
Yeah, we have a question about can data drift, data or feature drift be detected in real time? And I think knowing the description of today's workshop, I think that's one of the points you want to talk about, right?
Yes. So the short answer is, well, yeah, you can do different types of stuff to detect these drifts in kind of essentially real time, right? Like we'll talk about running some checks in your kind of local environment, and then we'll also talk about running these checks in kind of a cloud environment. So you can stream this data in and then get an alert when something changes. But yeah, so like in something, yeah, the shorter answer is yes, and we're going to get to that with some code, which will be cool.
And since I already interrupted you, so the polls, I closed the poll, so 48 people answered and 65% already work in data.
Awesome, very cool.
Yeah.
All right, so who should use data monitoring? And real quick, you don't have to make another poll, but in the chat, if you're already using some form of data monitoring, you should let me know. So I know, you know, people definitely in big teams and big companies, there's forms of monitoring systems in place. A lot of it, sometimes people are building them in-house because really the tooling wasn't around in the last several years. And now there's starting to be more and more tools. Again, we're going to use some today that enable people to do data and ML monitoring much easier. But some people, right, a data scientist, data engineer, a machine learning engineer, sensor fusion engineers. So even if you're not doing the ML part, but you're responsible for, you know, creating accurate inputs of data, you might be, or you should probably be using some form of monitoring to make sure that the data you're passing through your sensors are in the form that it should be. Data analysts, depending on the team structure, people might get mad at me in the chat saying that data analysts shouldn't do any of the data engineering. But most of them that I know, maybe it's because they're at a lot of startups, they do some form of it. And so it's good to still do some sort of checks when you can in your pipeline.
It's actually a funny story. In our company where I work with, one of the analysts was driving the, like he was implementing all these data quality checks through Tableau. So in Tableau, you have this a way to have checks, and he installed them. So yeah, not uncommon.
Yeah, makes a lot of sense. And I think I didn't get to this part yet, but we're going to talk about some of the types of failures, right? And it's not always related to an ML or a data pipeline. You might be doing some sort of analysis and you're creating a report, and you might be in a meeting talking about your numbers, and then you might get called out of the meeting for being wrong. So it's really important to build trustworthy data sources, kind of no matter what you're doing with data. All right, so we're going to go ahead and get on to the code. And again, if you want to follow along, the link to the Colab notebook is in the description, and the link for the YLabs free account. Again, there's no card or anything required. Just go ahead and sign up for that. We're going to use it in a little bit. And
maybe can you show us how to make a copy of a notebook? Or
oh yeah,
they just need to open the link and start.
Yeah, no, thank you so much,
lines,
because I usually have that written down and I totally forgot to put it in here. So this is a Google Colab notebook, by the way. If people don't know, maybe they've never used it. It's kind of Google's way of hosting a Jupyter notebook, which is a way where you can write text and code and embed visualizations and images kind of all in one place, which is really cool. If you've worked in data before, which it sounded like most of the people have, you've probably used a Jupyter notebook at some point. The cool thing about it is Google Colab is actually kind of a whole instance, in Ubuntu instance. So once you create a copy, which once you open up this Google Colab, you want to go to File, save a copy in Drive, and then I'm actually going to do this and run it on a copy as well, so I'm not messing up the copy as we go. This will give you your very own copy of the Google Colab. So feel free to make any edits to it, whether you want to take notes in here or you want to play around with the code. Like I was saying, I like doing that if I'm in a workshop and following along with some code. I like going ahead and kind of making changes and seeing what happens. So feel free to do that in your own copy. You won't mess up the original one. You can always go to the link of the original one and save another copy in Drive. And a cool thing too, we don't need to do it for this, but Colab is a really cool way to kind of get started in deep learning, where you can change your runtime type and actually select a free GPU or TPU hardware accelerator. So if you're interested in getting into deep learning and you don't have a GPU at home, Google Colab's a really cool way to use those resources for it. Thank you for the reminder, Alexi. And we'll see. So in this first code cell, let's go ahead and run it. We'll actually see, like I was saying, this actually is a whole little Ubuntu instance that you have going on here, not just a Colab notebook. So we're actually going to pip install a library that we're going to use in a little bit called YLogs, and we're going to pass in the viz parameter to install the visualization dependencies. So we're going to do some cool visualizations with it in a little bit as well. So this should just take a minute.
Will you tell us what YLogs is?
Yes, and it's kind of weird because I have us install it here and then I get to it in a little bit. But briefly, YLogs is a library that we're going to use that does data logging and has a lot of really cool features to detect things like data drift and model drift, as well as doing data quality validation. So we're going to get to it in a little bit. First, we're going to use this in the proactive stage. So first, we're going to see some failures, and then we're going to be reactive to it, and then we'll get to the proactive stage. But if you do want to check it out, I think the link to the YLogs GitHub is also in the description as well.
Mm-hmm. And I don't know if you mentioned, but it's open source, right?
It is open source, yeah. So you can go to GitHub and see all the code that's going on with it. And I'll talk a little bit about it in a few minutes, but thank you for the reminder to kind of briefly talk about what it is right now. I'll fix this in the Colab next time. All right, so we're going to import some dependencies that we're going to use in our project. So we're importing NumPy, we're importing pandas, we're going to import train test split from sklearn. And then don't freak out now, but we are going to import the iris data set, something that probably people have seen millions of times, but I promise you the data is going to get a little bit more interesting. We're not just going to stick with the iris data set through it. So just want to put that out there right at the beginning. Don't all leave right now where you're like, oh no, it's just another iris data set machine learning tutorial.
Yeah, maybe 65% of people are rolling their eyes now.
Right. That's why I want to be very clear. We're going to go beyond this. but what we want to do for this use case is we're going to train a machine learning model, and then we're going to bring in batches of data and kind of understand how to monitor that data, both before we run it, before we use the model to make predictions on it. And then we'll also look at monitoring the prediction results with it. So go ahead and import this. Also, as a neat trick that I didn't know for years, and I used to teach a lot of machine learning workshops, and I wish I knew this sooner, is you can actually import any of the sklearn data sets as a data frame if you pass in as frame equals true, which is great because then it saves us a step of converting it to a data frame. And then we're just going to print out. So we have 3 classes: Setosa, Versicola, and Virginica. And then in that data set, there's 4 features. So we have a sepal length, sepal width, petal length, and petal width. And you can correct me if I'm wrong. Pretty sure the sepal length, I had to look this up a long time ago, where it's kind of like the under petal of a flower. So you have like the main petals you think of a flower, and then there's kind of the things underneath it. And so these are the 4 features that are measured to understand which class of flower our data is going to belong to. So we're going to train a machine learning model very quickly. I think, there are still 30-something people who said they were learning about data. we're not working it yet, so I'll break this down really quick. But again, we're not going to spend a ton of time on this machine learning part. The idea is just to get a model kind of very quickly that we can start using to make predictions. So we're going to import neighbors from sklearn. We're going to train a k-nearest neighbor model, which I'll talk a little more about in a little bit. Then we're going to get our iris data. We're just going to create two variables, x and y, for the data, and then for the targets or classes that we want the predictions to be trained on. We're going to use train test split. So we're just taking that data set and we're splitting it up in 4 ways. This is pretty common in machine learning. Sometimes you'll do it in 3 ways. But we're making an x train, x test, y train, and y test. So we're going to train on these training splits, and then we're going to use the test to evaluate our model once it's trained, to make sure that it's at least kind of picking up on some stuff in the data set. So we pass in the x and y data to train test split, and we're going to say our test size is 30%, so it's going to train on 70% of the data, and then we set a random state of 42. So if we ever do need to see that state of the data again, we can put in the seed, and then we're stratifying on y. That just means that we're going to try to equalize the amount of classes that we're training on. So if you don't stratify on it, you might get a bias of like one class over the other. So we're trying to pass in the same number of data from all the different classes, so our model isn't biased. Then we're gonna hit fit. So we just say k-nin fit, and we pass in the train data and targets, and then we're gonna get the prediction. So k-nin predict on test, and then we're gonna look at the score. So here we just see our score on our evaluation data set. Our model's 95% accurate, which again, accuracy isn't always the best thing to measure on. But also, if you've never worked in data before, I just want to say that maybe you've trained your first machine learning model right now, which is really cool if you've never done that before. And hopefully, if you thought machine learning was really crazy, obviously there's a lot more to learn than just what's going on in this code cell. But you could totally do machine learning kind of, if you're interested in programming at all, and this doesn't seem too crazy to you, definitely look into some more machine learning resources. Real quick, we're just going to print out something called a classification report. It just gives us more measurements of how our model's performing. It's not really important for this workshop. All right, so just a little bit of intuition on how the nearest neighbors model works. In this case, we trained our model to have n neighbors of 3, which means when we get a new piece of data, and we're just plotting this out in 2D with features, right? So we can see petal width and sepal length. If we got a new piece of data that landed right here, where this black dot is, and in this case, it's looking at the closest 4 neighbors. So this example is trained with like nearest neighbors of 4. Basically, what nearest neighbors means, you get that new piece of data, and then it's going to look at the closest data in the training set and infer, okay, well, I'm closest to these 3 pieces or these 3 classes, and then essentially assume that it's going to be that class. This is important just because when we get to the troubleshooting in a second, we can kind of maybe reactively understand like where our data is going wrong. Any questions so far, real quick, from anyone?
Yeah, there is a question, but I think maybe it makes sense to cover it later. So there is a question how YLogs, YLabs compare to Evidently and other tools, but maybe we can keep it for the end, right?
Yeah, we'll go through and you'll see some examples of it.
Yeah.
All right. So we have our model trained. You have a little bit of intuition how this works. All right, so let's go ahead and bring in our data batches for our prediction. So here I'm just bringing in like 8 different CSV files, and you can just run this code cell. And for some of them, there are targets in there. So you could use this later to kind of understand how your model's doing with ground truth. We'll talk about that later. But essentially, we're just bringing in 8 CSVs and making data frames out of them. And then we're going to have an array of data frames down here. All right, so let's go ahead and use these batches to make predictions. So I already have the output down here, but let's go ahead and run this code cell. So we're making predictions with our nearest neighbor model. And we can see that there's 0s, 1s, and 2s, right? Like this looks like if we knew that there's, kind of an even number of classes that it should make predictions on. This looks okay. And we'll run it on 2, and we'll run it on 3. And technically, we're kind of cheating right now a little bit because we're looking at it. We're kind of monitoring the data. So you can imagine that our model is just running in production, right? Like we're not looking at every single result usually, probably when our model is running. So we're kind of cheating here a little bit, but this is to get an idea of like where our model could fail or where our data could fail. So this one looks a little different, right? It's all zeros. Maybe that's not right. This one is all 2s. Again, like a little different than our original profile. So if we were expecting our profiles to be very similar to each other, maybe that's not right either. And this one is also all 2s. And then this one looks like fairly normal distribution again. And then let's run this last one. And this actually threw an error. And it's saying, could not convert a string to a float. So that gives us an idea that, there's probably a string in there when it should be expecting a float number. But it's interesting, right? Only one of these failed. Does that mean that everything else is fine? You let me know in the chat. Spoilers, it's not. So what are some ways that our data and model might be failing? Now, we talked about kind of the intuition, right, of like we get a new data point and then we're going to look at the closest number of neighbors. And in our model, we trained it for 3. So we get a new data point and then it's going to be looking at the closest kind of 3 values to it and then associate that new data to that class. So what would happen if we train a model like this and then we got a data that doesn't really fall into this distribution? Maybe it's over here. So instead of being like 2.5 and 7.5, it's something like 12 and 10 for the sepal length and petal width. What would happen if that happened? And as a spoiler alert, it's going to still make a prediction, right? It's going to look at the closest 3 values and assign it that class, because we don't have anything built into our system right now that is saying this data should fall within this range, right? So what would also happen if we had a value of 0, which seems weird because if we're measuring a length of something, it's probably not 0, at least in this case, because otherwise the flower just isn't going to exist if it's zeros. So if we had all zeros, it still is going to look at the 3 closest neighbors. And in this case, right, it would see all these setosa values and then make that prediction of 0 of that class. What would happen if we had negative values? You're probably getting the idea right now, but it could be way down here. It could be all the way off the chart, but it's still looking at the 3 closest ones because we don't have anything that validates our data is actually in the proper form or that it falls in the range that we're expecting, right?
Do you have some of these examples that you mentioned in your data? Or
maybe.
Am I asking too early?
Right. So the only one we had fail is this one with a string. And right, if you're kind of new to development, maybe you haven't realized this yet, but getting a failure is amazing. Getting an error because something went wrong. It's scary when something isn't working and you're not getting an error. That's when something's really bad. And it's much harder to troubleshoot. So I always tell people when they're getting started with anything, right? Like errors are awesome. They're your friends. They're trying to tell you what's wrong. And it's much more scary when you're not getting an error at all, but something just isn't performing right. All right. So in this case, we kind of already looked at our data, right? So I was saying we were kind of cheating because we were technically monitoring it well as doing the predictions, but only one of them had the visible failure, and like I mentioned, that doesn't mean all the other ones were fine, and we'll find out more about analyzing them in a second. But in this case, how would we know that we would need to look at our data if that happened, right? So we have customer complaints. That's really bad. So you could have a model or data in production and customers send you tickets or complaints about it because something just isn't performing right. You could do manual checks. When I mentioned the factory one, right? Like that's something that's like, oh, every couple of days, maybe we go look at this camera feed and then we found that it was dark. So that's cool that we found it, but we should have some sort of alert for that instead. the report is called out wrong in the meeting. We were talking about data analysts before, how you should have some sort of check, even, if you're not a data engineer, probably, right? Like you can write these in Tableau to do similar things. You might notice change of behavior, like on your website, if you're kind of making recommendations or something, and you're thinking like, why is no one buying this thing that I thought they would be doing? There could be a change of behavior because you're not recommending something or you're not placing the button in the right place. So let's real quick look at some reactive manual analysis. So this isn't the exciting part. We're going to go through this pretty quickly. And like I was saying, I think most people have probably done this in the past if you worked in data, right? You've probably done some sort of manual analysis because you've had something go wrong. Right. So the easy way of doing this is one, we could just kind of look at our data frames and describe them and get some statistics here. So here we're looking at batch 1. We can get a baseline. Well, this one seemed pretty good when we were looking at it manually. And so we can get a little bit of an idea of what maybe the ranges should be if we think this is a good profile. So we can see, our min and max is something to pay attention to. So when we look at the other profiles, like, do they fall within this range? And we're just going to eyeball it right now. So let's go ahead and look at data batch 8. And this one looks really weird. This is the one that failed with the strings. So you can actually see that there's strings of 0 in there instead of actually the number of 0. Look at data batch 4. This one is all zeros. So this doesn't look right. Definitely does not fall in the realm of this data batch. Look at this one. This one's really high, way higher. Our min is, in the hundreds. That's probably not right if our other batch is correct. And then we'll look at this one. This one doesn't seem too crazy, but if we did go look at the min and max, they still might be a little bit higher than what we were expecting. So this could be, again, right, like we're using the ML application, but this could be from any entry or input error at some point in the pre-processing or the entry point of the data collection. And if we're not actively monitoring, these types of batches could be running for a long time with these issues, and we might not notice it, especially if our model isn't throwing any errors or anything, right? So has anyone been in this type of situation before? Again, my guess is probably yes. You've probably manually done some analysis on it. Oh, I like how you put a poll in. And as an extra bonus, if you want to type in the chat, how did you figure out something was wrong? Did you get customer complaints? Did you get to that point? Were you manually checking and then you saw something was wrong?
I was just actually waiting next time you ask something with a poll.
Oh, you're ready.
I kind of like doing this. It's fun.
That is fun. It's nice having someone else on the stream with you too to kind of like bring up the questions or do something like that. All right. So as people are answering those, we'll go ahead and move into the next stage. Let's be proactive. We're going to implement data quality validation as part of our data and ML pipeline, so to hopefully avoid some of those failures. So we're going to use YLogs, which I shared the GitHub several minutes ago. So YLogs is an open source library for logging basically any kind of data. If you can put it into an object or a data frame, you can log it, which is really cool. So you can log unstructured data as well. So like I mentioned images before, doing stuff in computer vision, you can actually extract statistics from images, such as like the RGB values or the sizes of the images themselves, which could indicate some sort of quality problem. And how YLogs works is that they actually creates statistical profiles. So it actually will look at whatever you pass it in. So in this case, we're going to pass in those batches of data, right? There's like 300 plus, I think, in most of those batches. And what it's going to do is extract statistics from it. We're going to see it in a second. We'll look at a profile and analyze and see everything that's in there. And just to mention, they're super efficient. So they don't contain raw data. They just contain these kind of statistics of the data that we passed in. So they're incredibly lightweight, which is really cool. As someone who's done stuff with robotics and edge devices, I'm actually really excited working on some content right now about using these profiles on really kind of constrained devices where you don't have a lot of storage and you don't have a lot of processing power. So like the efficiency is really cool there when you're, passing them from one system to the other or to another. There's also a blog post I haven't linked in the colab as well that talks about profiling versus sampling. So we profile the whole data set that comes into it. They're customizable, so you can actually do a lot of customization on the metrics, and then they're mergeable. So if you are streaming data in small batches, or like I was mentioning, using edge devices, I might actually want to make these profiles and then merge them together. So instead of just having like a stream of every minute or something like that, I could build out batches that then become hours, or profiles that are then hours of data, or merge them together to look at a profile of like the entire day. And so with these statistics, again, we'll see it in a second, you can actually do a lot with it, such as track changes in the data set, create data constraints. So we'll look at like when the data doesn't match what we're looking for and throw some sort of error, and then quickly visualize like key statistics about the data, as well as detect data drift, model drift, all the things we kind of talked about. And you can put these and use YLogs at kind of multiple steps in your pipeline. So you're not just looking at one output, you're actually kind of looking at every time you transform data, every time your model does a prediction, you can log all of these, which we'll see in a second. All right, so first I'm going to set the pandas option to show max columns, because the profile we're going to look at is going to be a pretty big pandas data frame. And what we're going to do, oh no, what did I do wrong? Oh, I did not import YLogs. First, you have to import it. And then we're going to create a YLogs profile. So how we do that is we're just going to pass in that batch of data that we had. Again, this is a data frame, and we're just going to call y.log on it. Then we're going to create something called a profile view. This is going to allow us to kind of look at these statistics. And with that view too, again, we'll see in a second, we can use constraints, which does data quality validation. And then we can actually look at data drift with the visualization as well. And this is all done in your environment with the YLogs library. So I think I mentioned, right, like we just take these statistical summaries of your data. And the cool thing about that is you know, when you do move these off of your environment that you're doing maybe these quick checks in or collecting data, it actually doesn't contain any raw user data. It's actually just a statistical profile. So we have people using YLogs in industries that a lot of people wouldn't necessarily move raw data off of. So like in the finance industry or healthcare, and they'll actually use a profile and then send that profile somewhere for analyzing over time. So if we look at this profile, this is kind of what we get for statistics. In this case, our profile is numbers, right? So we're getting things like distribution. So we can scroll through. We get cardinality. So this is an estimate of like how many unique values there are. So we had 300 rows in here, and there's actually about 300 unique numbers. And that's because when I generated these data frames, there's actually quite a few numbers, and I didn't make them integers or floats. And so each one is actually a unique number in here. So it's kind of cool. You can see how many unique numbers are in your data set. You can see counts if there's nulls. You can see counts of numbers. So we have 300 in this one. You can, again, then see all these distribution max, the mean, the medium, the min, and all the quantiles. So with these statistics, we can actually calculate things like, does the data fall in the range that we're expecting? Does it, if we take multiple of these profiles, so we can take two and then compare them together and actually see, do the distributions match? Are they close together? Is there a big data drift? And we'll see how to do that in a second. So let's go ahead. We're going to make a profile view for each one of our data batches. And let's look at a couple just to see. So here is data batch number 5. And this is the one that was in the hundreds, so really high value. So we can immediately see if we're just using this to kind of do the reactive analysis, we could also see that this looks pretty high compared to the other profile. And let's do profile view 6. We can see this one looks a little bit higher than the other one, but it's not like a crazy value like in the hundreds. So maybe actually, right? Maybe if this was a seasonal thing, I'm making this up because this isn't actually true. But if iris flowers in the winter, for whatever reason, have really small petals, and then in the summer now they have really long petals. This could be a thing of like seasonal data drift, that we could look at this, see, hey, there was a drift in the data and model predictions, and we might need to retrain our model now with the summer data.
And there was actually a question if the drift occurs in time series data. This is a good example of when it does occur. And I think the general answer to this question, yes, drift occurs in time series data a lot.
Yeah. Definitely.
It's like I cannot think of any other type of data where it occurs less than in time series.
And it's interesting, yeah, because when you're building time series and you're probably trying to take seasonality in as it, but also if there's a big event, like a good example is, COVID threw off a lot of time series models when COVID happened and everything shut down. And you could say maybe that's an example of model drift, where the time series model no longer really matches what's happening in the real world. And so like, I think so many companies' models were off after that event. Do you have anything else to say on time series?
Nope.
Well, I need a drink of water anyways. So just to recap, we just looked at profiles real quick. Now we're actually going to get to the fun stuff of using them to do things. But the profiles are efficient, they're mergeable, they don't contain raw data, and you can use all those statistical properties to calculate things like data quality and data drift, which we're going to see right now in this section. And I have links in here to read way more about YLogs, examples, profiling versus sampling. And then also there's a link to a previous live stream we did when we released V1, which is what we're using right now. And they talk a lot about the kind of efficiency of it. So it's really cool about, you can take thousands of features in a data set, condense them down into this really lightweight, efficient profile, which is awesome. So if you're someone with thousands or hundreds of features and it's kind of getting hard to move all that data around and do things like detect drift on it or data quality validation, you might want to look at using something like YLogs. So let's look at data quality validation with something called constraints in YLogs. You can see here's this cute little animation. We have some data flowing in, and Ybot is that's what we call this guy, is looking at the data flowing in and seeing if it's good or bad. So in this case, we could say that maybe we don't want null values, we don't want negative values, we only want numbers that are whole numbers in this case. And if they're anything but that, then we don't want to use them, or we want to throw an error in some way, or do some sort of trigger in our system. So data quality validation ensures data is structured and falls in the range expected for data pipelines and applications. So when collecting or using data, it's important to verify the quality to avoid unwanted machine learning behavior in production or data, right? It doesn't have to be machine learning, such as like we saw like those kind of faulty predictions, right? If it was all zeros and we know that that shouldn't exist at all, then we probably shouldn't be running predictions on our model. Or if we are, we should have some sort of error and say like, this is probably wrong, and we want to go figure out why it's wrong. So let's go ahead. We're going to import constraints from YLogs and some constraint helpers. And then we're going to create one real quick here. And then we're going to kind of talk about how to tie multiple ones together. So the constraint is going to allow us to look at that profile like we saw before and say, when one of these things, it is out of this value range, throw an error, or if it's within a value range, throw an error or do something, right? So with any of those statistics, we can look at them and then do something with that data. So here, I'll go ahead and just run this. And so we're initializing our builder. Then we're going to add a constraint. You can add multiple ones, which we'll show in a second. So this one, we're passing in a name. We're going to say, string type should equal 0. We're going to say we shouldn't have any strings in our data set. We're only expecting numerical values. And then we're going to use a lambda function to set the condition. We'll come back to this in a second. We're going to use metric selector to select, in this case, we want to look at the column petal length. And then we're going to look at types, which is one of the statistics that we're gathering in the profile. And then we're going to say, all right, so we want to say types, the string type is equal to 0. So if we run this, we get this result back. It's the name, string type equals 0. and then we get this 0 and 1. This first one means pass. So if this was a 1, it would have passed. And if this one is a 1, it means it fails. So if we go back and look at our profile real quick and scroll, oops, keep opening this up. All right, if we scroll down in here, we can say type string. We're not looking at the profile that we're running the constraints on, but we're saying, right, like types of string, and we're expecting 0. We don't want, we only want numerical values. So this profile is good, it's only 0. But this one contained some strings, so it's actually failing our constraint. So let's add multiple constraints together real quick. Also, just for timing, I'm going to go a little bit faster because just to make sure that we cover everything, and then we'll answer questions after. So we're going to create a function. We're going to call it validate features. We're going to pass in a profile view. And then I like a lot of my functions to have this kind of verbose option where I can say true or false, and it gives me a little bit more details. Then we're going to do constraints just like we did before, but we're going to add multiple ones together. We're going to say, all right, so for the petal and length and width, and then the sepal length and width, we're expecting them to be greater than 0. None of them should be 0 or below. And then we expect them also to fall in the range of less than 8. So if anything, or sorry, so I have 8 in the description here. I should have updated this to 15. So this looks a little bit wrong. We're actually checking to make sure that they are above 0 and they're below the value of 15. And so we're just doing that 4 times for each of those columns. And then we're building our constraints here. And then we're just going to return that constraint object with our function. So let's run that. And then here I'm running it on profile 1. And we can see that all these different constraints, right? We got 4 tuples returned, and it looks like they all pass. We have 1, 1, 1, and the last one in the list is always 0. So that's good. They all passed. Us as humans are visual people. So this is great if you're running something, you want to trigger something based on it. Like if something doesn't pass, you could use this and look at it and do some sort of trigger. But if you want to look at a nice report, you can also use the notebook profile visualizer. So this is really cool if you have like a bunch of features that you're running constraints on, and you want to make sure kind of they all passed, or what passed and what failed. This is like a cool visual way to kind of see it. So let's run this on another profile. Oh, sorry. First, so this is an easier way to quickly see if they all passed or if any failed. So we can use this kind of constraint validate property, and this is just going to say true or false. So in this case, it's true, they all passed. So we could go ahead and go on to the next step. So if I was collecting images or something, right, going back to that analogy of like images that were too dark, if I was collecting that data and I was looking at pixel values for darkness, and this case they were all light enough, and it says, hey, this image looks good, go on to the next step of the pipeline. We can use this validate. So let's do it on another profile. We're going to look at profile 4, and we can actually see quickly here again in this tuple, or this list of tuples, that it looks like they all failed. And let's go ahead and visualize that again. We can see that they all failed here. And then if we use that validate function, false. So this is a real quick look at using constraints in YLogs. It's a really cool way of creating those profiles and then using them to kind of either trigger or stop a pipeline, or stop something in a pipeline. It's kind of like unit testing for your data. So you might have written kind of some sort of unit test for software before. And in this case, you're kind of just doing it for your data set, and then you can do whatever you want with it. And again, there's a lot more resources in here. You can, again, use it throughout your pipeline. So anytime you're doing some sort of transform or input to validate that it's kind of looking how it should look. So the cool thing is, like, you could look at those ranges like we talked about, but you could also look at, is this the correct data type, or did it accidentally become a string when it should have been an integer?
And
we also have
yeah, sorry. Maybe this is something you actually wanted to talk about right now, because I wanted to ask, like, how do we actually integrate it in our pipelines? Do we, like, let's say we have a data pipeline, data preparation pipeline, data preprocessing pipeline, whatever. And then let's say we have multiple steps. We have a step with feature engineering. So we do our, I don't know, a SQL query that goes and prepares all the features we need for the model, and then there is another step after that that takes in these features and then applies the model, right? We, I guess, take these checks and place them between these two steps, right? It becomes like a third step, which is between the first and the second one, which checks the data before we feed it in our model, right?
Correct. And you can create a profile at each of those stages. And so we'll talk about kind of logging those profiles over time, which is a really neat feature. And so there's writers that you can use for YLogs. So you can make a profile of your data set at all those different steps, and then you could send that somewhere. We're going to send it today to YLabs, which is kind of the place where you can easily send these profiles and kind of do all the things we're doing right now, but way easier with way less code, and then managed, over time. But yeah, you can do, basically, I would create a profile at each of those steps, and then you could write these constraints, or like I was saying, coming soon, we have something called auto constraints. So you can actually profile your data sets, and then it'll kind of figure out, okay, if you don't want to deviate too much from these profiles, we can automatically figure out, the distributions or what they should be. And then, so you could log the profiles and then write them out too. So like a lot of times, right, if you're generating these profiles, it's cool to do a quick check on it, but you also want to save these profiles over time to look at things like drift, which we're going to do in a second. Does that answer your question?
It does, yeah. And there is another question. I guess we're now moving on to the next topic, right? So maybe it's time to ask this question. It's actually the last one if you're looking at live chat. So the question from Arturo: do YLogs support tracking different data versions? For example, data batches having different features. And I guess a good example would be, let's say now all of a sudden we decided to measure 3 things from flowers, right? Or 4 things. I don't remember how many features we have in this Iris data set. So let's say we measure another thing now. Like, does it support tracking? I guess when you create a profile, it will just have one extra column there, right?
Yeah, I'm trying to think of the exact use case of that question. Like, it's not oh, sorry, go ahead.
Yeah, maybe a use case, I guess an interesting use case would be when you expect a feature that disappears. More rather than,
gotcha.
a new feature. Like if you have a new feature, it will not do any harm to your existing model. But if a column disappears, then it's bad, right? And you probably want to detect that. But on the other hand, you mentioned when you see an error, it's actually a good thing. And that will cause an error, right? It will say, okay, hey.
I believe it would cause an error for sure if you tried to like run a constraint on something that didn't exist. I don't know. I don't think there's like a explicit tracking of that built in that I know of.
Mm-hmm. Do you track any metadata? Like how schema evolves over time?
No? I mean, you could. So you can log kind of anything that you want in here over time. But I don't think there's like the metadata that you're probably thinking of that's tracked automatically in here. But if you have a use case for it, let me know too, because we're always looking for ways of improving the product and adding features that people want in there.
And the best way to let you know is through the Slack community you mentioned.
The Slack community is probably pretty good. If you connected with me on LinkedIn, you could let me know there as well. But the Slack is great because all of our engineers are in there as well.
Sure.
But yeah, the thing about the profiles that's cool too is like how customizable it is. So if there's any metadata that you want to bring in, you can bring those into profiles. And we do have an option of tracking like frequent items that come in too. So if there's something about like a metadata that you want to see, like, well, most of these came from this resource or something like that, you could get a cardinality estimate of like what resource they did come from. All right, real quick, let's run through this drift stuff. And again, I'm going to pick up the speed a little bit just because I want to make sure we get into YLabs. We're already almost an hour in, which is crazy. I'm having such a great time. So data drift. Here's an example of 2 profiles being compared to each other with YLogs. And so we can actually see that, the distribution of these profiles looks a little bit different. There's some overlapping. But one is way higher in these areas and also goes, the values go much higher than the other profile. Like this one definitely leans towards this, 0.9 value, and this one's going into the 1 quite a bit more. So this one, we're kind of seeing like we have two profiles and we're comparing them. How similar are they to each other? And we're going to use this to kind of detect data drift with the visualization part of YLogs. Again, I'm going to go a little bit faster. We can come back to this if we need to, but I just want to make sure we get into the part of using YLabs, which is right after this. So we have our profiles that we already created. We're going to import notebook profile visualizer. We're going to initialize it. And then we're going to pass in two parameters here, basically a target profile and a reference profile. So these are the two profiles that we're going to compare to each other. Here I'm using profile 1 and profile 2 at first. And let's go ahead and print out this profile summary. This is actually just giving us some quick statistics again. It kind of shows the distribution of the different features. But what I really like is the drift report. So this shows us, again, kind of like but this isn't overlapping quite yet, but here's the two profiles side to side. And you can kind of see like if they look very similar or not. And then you have these values. So the p-value here is calculated with KS test, which is essentially a model for detecting drift between distributions of data. And if this value is very high, like 1 or 93, that means there isn't much drift. And then if it's lower than that or 0, that means there's a lot of drift between those two profiles calculated with KS test. So this tells me, cool, all these features, they're pretty similar, right? Like these ones actually have 1, they're so similar. And then there's one with 93 and there's one with 88. So we're basically almost in the 1 range and then in the high 80s and 90s, which means there isn't a huge amount of drift happening with this data. If we overlay the features on top of each other, we're looking at petal width here. You can see that, yeah, right, like there's a little bit of difference. They're not 100% the same. You would expect this with most data sets, but they all fall within the same distribution. Like there isn't any way out off to the side. They're all basically within the same value range. And we can look at the other one. This is the petal length. So this one I think had a tiny bit more drift just because there's a little bit of a shift in distributions for some of these numbers. This one's even more similar. And quickly, let's go and look at profiles that aren't as similar. So we'll just run this again. It's just like what we did before. We can see real quick on this profile that the numbers we had before was almost 1 or in the 90s. This one's 0. This one's such a small number, right? It's not printing it out in a float. And if we overlay the visualizations like we did before, we'll actually see there's a big drift, right? So like none of these are actually overlapping at all. That's why it was 0. Basically, there's a major drift happening here. This data set isn't really matching the previous data set. Again, I have links to more about using the data visualizer to detect things like data drift. You can also save these, again, like save the profiles, you can save the visuals, and all that's talked about in the GitHub link if you want to read more there. And again, I'm going to move pretty fast because I just want to get through the YLabs part as well, which is really cool. And then we'll come back and answer any other questions that people might have.
But so you forgot to mention the important part, to give a star to YLogs.
Yes.
I see it in the notes, but you didn't say it out loud. So please,
right. Thank you. Yeah. The most important part is to give a star to YLogs. So if you go to that GitHub page and you think this looks cool, or you don't think it looks cool, definitely give us a star. Or if you're enjoying the workshop,
either way, right? Yeah. Give a star.
Give us a star for sure. It doesn't matter what you think. Please give us a star. It definitely helps out our project. So if you think this does seem interesting or something really cool, definitely go ahead and star it and come back and look at it. So we're always making really cool updates. We have a cool new release coming out in a few weeks that I'm really excited about. That's going to have some new features around images, which I keep talking about, right? Where we have some functions coming out that will be able to extract statistics from images built into YLogs, which is really exciting, as well as some other stuff. Someone mentioned at the beginning of doing some NLP support, I think, right? I forget the exact question, but we have some string stuff coming out in a few weeks as well. That'll be some basic NLP stuff. And then we're going to have a lot more NLP support, I think, in the version after that, which will be really cool. Something that people definitely are asking for and that we're excited about. But we saw real quick in YLogs, right? Using it in your Python environment, you could do things like data quality validation. You can even check data drift in there. So now we're going to go into the next stage. Again, moving a little bit faster here just to make sure we get through all the content. We're gonna look at doing an end-to-end monitoring as data moves through your system. Again, our examples today has been pretty simple, right? We're just taking in data and then we're looking at it before we make predictions on it. But you might have a much bigger data pipeline, like you're saying, all the pre-processing steps, feature engineering, input. You might want to be monitoring all those different places in a system. And like we mentioned, using YLogs at all those different points. So instead of using YLogs at those points and doing validation right then and there, which you totally could do because you might want to, have a trigger do something in your pipeline. What we can do is we're creating those profiles there, and you could still do those validation checks, but we're going to send those profiles up to an observability store. So we're taking those statistical profiles, we're going to upload them to YLabs, so we can look at kind of the data over time, and we can do forecasts, we can detect anomalies, and kind of gain a lot of insight around our data, as well as do alerts and notifications really easily, and triggers as well. So like we integrate with email, Slack, PagerDuty. So kind of anything you want to do. Like I usually have emails on for my hobby models that I'm monitoring, and I get a report, if something goes awry, like in something that I'm monitoring. If you haven't already, create a free account. So we'll actually walk through setting up data from this notebook. We're going to stream it out into YLabs. So now is the good time to create an account if you haven't. All right, so if you are one of those people where you just hit run all in the notebook, and you probably got here, I just threw a break in just so before the next step it won't run. That's because we want to get our YLabs API key and our YLabs org ID. So I'm going to open up YLabs. And I do have images in here. If you kind of if you save this notebook and you're going through it later, you can come back and kind of look at these images and probably figure out what to do. But for now, I'm going to go into my YLabs account. So yours won't have projects in here yet, and you'll see this create project button. We're going to want to go ahead and do that. And there's also an option for adding a demo model. So if you're not following along with the notebook right now, but you actually do want to take a look at YLabs, you can hit this add demo model, and it'll automatically put in some demo data, so you can kind of poke around and do the other stuff that I'm going to show you in YLabs. But for us, I want to send data out of my notebook into YLabs itself. So I'm going to set up model, give it a name. I'll just say work shop with the date. But you should have probably a better name than that. And then you can select the model type. So you can leave it unknown. And again, it doesn't have to be a machine learning model. So you don't have to say classification or regression. I'm going to go ahead and select classification. For this workshop, it actually doesn't really matter, but it is something that you can select to look at performance over time, which we'll talk about in a second as well. So I'm going to hit create project. And we see that this is added. Workshop August 16th. And you can see the model ID or project ID is model 18. So I'm going to copy that. And so if you did this, and you've never used YLabs before, it's probably model 1. Go back over to our notebook. And I'm scrolling past these pictures. So I want to put in my project number down here. It's this last one, YLabs project ID. Now I want to go get my API token and my org ID. So I'm going to go back to YLabs. I'm going to go into settings with this little hamburger menu. Settings, access tokens. Give your access token a name. Again, I'll just say workshop Aug 16. You can set an expiration date for it if you want. And I got to move this Zoom video real quick because it's going to be in my way. You'll also see the org ID is already here. So you could copy that right now if you want. I'm actually going to do that. Zoom video is hiding it. So I'm going to copy that first, bring it over to my notebook, put in my org ID. And then I'm going to create my access token. So this will only show up once here, copy it, and paste it in. So now we should be set up to start streaming profiles, YLog profiles into YLabs. So let's go back to YLabs real quick. I'm just going to go to my home here. I see I have this kind of blank project where, there's no data going into it right now. So we'll go back to our notebook. We're going to just kind of install YLogs with the YLabs dependencies. We'll import YLogs as Y again. We have pandas, we have OS, we have YLogs writer, which is going to send the profiles to YLabs. And then here we're just assigning all of our ideas that we just got into environment variables. And get an error in Colab, but I think it's okay. Don't worry too much about it. I always feel like every time I do any workshops in Colab, I always get these errors and then everything's fine. So don't worry about it. And then what we're going to do here is just backfill all those profiles that we created with YLogs, or sorry, our pandas profiles, our panda data frames. What we're going to do is just create a profile for each one and then log that to YLab. So this is not that much code. This is only like 8 lines or something like that. And this is just a for loop, taking all those data frames, those batches that we have. We're going to create those profiles. We saw what those profiles look like, and then we're sending those profiles up to YLabs. So it's enumerating for each one in the data frame list that we created near the beginning. We're adding a date time to it, so you can adjust this date time. For this use case, we're just saying for each data frame in the data frame list, just start with the number and subtract from it. So this is backfilling like the last 7 days. I think we had 7 profiles or 8 profiles in there. So it's basically just going through and adding a date from today and then subtracting 1 day from it and adding it to to YLabs. So now if you ran this and you refresh your screen here, we have workshop August 16. We can see some data is going on in here. There's no alerts right now. Let's go in. And we can see that all of our input is in here. And so this is all those YLogs profiles that we looked at before, where we have all those kind of statistics that we can gain insights from and detect things like data drift or data quality. And this drift distance will show up once our trigger happens. So let's go ahead real quick and we can click into one of these.
Zoom in a bit?
Oh yeah, thank you. Is that better?
Because this gets interesting. I think it's important if it's yeah. That's better.
And so you can scroll through, kind of see the things like data, total count of of the data that was in the profiles, estimated unique values, data type counts, and then we can click into these features and see that they're visually, we can kind of look at this and see there's probably some big changes that happened. Our profiles look like they're, very similar to each other. And then all of a sudden there's some crazy spike and then it looks a little similar to each other again. So we're just visually inspecting right now, but we're going to set up an auto alert for us. So anytime something like this happens, we can get an email, we can get a Slack message, or we can trigger something else using like a PagerDuty integration. But real quick, before we set up the alert, we can also inspect our profiles. And this is kind of similar to like how we're looking at the visual drift detections. We can add up to 3 profiles here to kind of get an idea of how the distributions look. So let me add another one. I think this first one is maybe the 0 one or something that doesn't quite look right. Doesn't look like the other distributions. Maybe that's the 0 one. Let me bring in another one. I forget what order they were all uploaded in. So this is, again, we're manually inspecting. So we can see these 2 profiles, again, are very similar to each other. So they match the distribution. And this one is a little bit off, right? Or maybe way off. And then, so the exciting thing here is the automatic monitoring. So you can go over to Monitor Manager. We have a lot of presets that you can choose to kind of pick from of like what you want to get alerted for. And then we also have custom monitors. So you can even take a preset and then customize it a lot to do kind of exactly what you want it to. So in this case, we're going to look at all non-discrete inputs and compare to a 7-day baseline. So we're going to enable with one click real quick, and we'll come back to this in a second and talk about configuring it. But first, let's go back to our inputs and click back into a feature. And let's preview what that monitor looks like. So the monitors run every once 24 hours right now. So it says the next monitor is going to run in about 8 hours. I think it's 12 a.m. UTC time is when they run. So automatically you'll get this trigger happening every once 24 hours. But we can preview what this monitor looks like. And we can see that, just by the default configuration here, we're getting some errors, which is good, right? Again, this is great getting some errors because it's not data, or it's not great if we didn't want this, but in this case, we want to know when something goes awry in our data pipeline. So here we can see if we hover over this, we can even see what the min and max values are for those profiles. And if we drag over this error, we can see that it looks like there is quite a big drift. The max went from, what was this, like 6 to 11. So a pretty big shift there. This one's even bigger. This is that profile that we saw earlier with like the 100 values. This one is the one with zeros. So again, a pretty big shift. And then this one's actually fine, right? Like this is the other profile that kind of falls in that distribution window that we were expecting. And then this is very interesting. We actually don't see any line drawn here because this is the one with text in it. So this actually didn't draw the distribution of numbers. But if we click this frequent item tab, we can actually see, instead of the distribution values, we have some categorical values because things came in as a text. If you want to set up alerts, go back to settings, go to notifications and alert digest. So I often have emails for mine enabled because, a lot of stuff I'm doing right now is just like hobby fun projects. I don't need like a Slack message, or I don't need a PagerDuty integration, but we have those as options as well. And it's really cool just how easy it is to set up your email in here. So anytime one of my edge devices or something sees something different, I get a cool little alert with it in my email. We also have a lot of integrations. So you can go to, again, more on the YLogs side. So I think we have an integration list. So if you're using things like Kafka or Flight for your pipelines, we have kind of nice integration and docs to set it up pretty easily there. Let me make sure there wasn't something else that I really needed to show. Oh, so I forgot to go back to the customization part. So we'll go back into our project, go to Monitor Manager. We have this one enabled right now. We scroll over. We get some options, like if we want to edit it, and we have a whole bunch of options here. So we can do things like detect drift, data quality, throughput, and then a lot of options, like if we want to do discrete or non-discrete values, and the type of distance that we want to measure for. So in YLabs, we use something called the Hellinger distance to measure drift. Hellinger works good for categorical and numerical values. So I think you saw in YLogs, by default, use KS test, kind of a similar thing, except for just a little bit different way of measuring it. You have an option for how to trigger these alerts. So by default, it's a trailing window. It's going to look at the profiles over time and then trigger an alert when something drastically changes. A lot of people use this because, right, like like I was saying, this would capture a lot of the use cases we talked about. If we were measuring that computer vision feed and we were looking at brightness values over time, and then all of a sudden it went dark, it would trigger an alert. For seasonality, it could also trigger an alert. So again, like I talked about, a model looking at livestock in green grass and then in white snow. Again, if we were monitoring those RGB values over time and looking at this trailing window, and then all of a sudden one day you had all these white values instead of green, it could trigger an alert there as well. So trailing window is really good if you're maybe like you know that the data is good going in, and then you're looking for these kind of drifts happening over time. But you can also select a reference profile. So people do this with their training data set. You might say, all right, I have my machine learning model here. I want to be notified really anytime that the new data drifts a lot from the training data set. You can also do a specific date range. So if you know there are some data sets, or if you know there's some data that you really trust, and then you want to compare new data to that, you can do that here as well. And you can also set things like priority and little custom messages to yourself in those emails. So I could say like, well, if this alert specifically for this monitor is a low, medium, or high priority. And then real quick, just going back to the monitor manager. It just looks different because I'm zoomed in so far. You'll also get anomaly feed. So in this case, we just did that preview of a trigger. So there's nothing in here. I can show another profile in a second if we want. And we can also go back to presets. This is where we selected the one from. So we have them kind of segmented out in ways of like monitor for data drift, monitor for data quality, model performance, which we didn't get to yet. It is in the notebook. I'll briefly talk about it for a second, but we won't go too deep into it just based on time. So you can select things for like if you're monitoring model performance, which I'll show a preview of what it looks like. You can be, and this is coming in a few weeks. So on the release I was talking about, I think it's September 9th. Right now you can do this in YLogs v0, but you can't do it in v1 right now. But again, in a couple of weeks, you'll be able to log the performance metrics. So you just give it the predicted outputs and the ground truth outputs, and then you can monitor things like accuracy over time, the ROC, the precision recall, the confusion matrix, and then basically you can set a monitor on any of these. So if the precision falls a lot, you can get a triggered alert for it. Or if the F1 score falls a lot, you can get a triggered alert for it.
May I ask a question?
Yes, yes.
Or because I wasn't sure if you want to say something else. There was a pause. I thought, okay, it's time to ask something maybe. I'm just trying to understand the pattern, how exactly we should use. So in the previous one, was it proactive, reactive? No, like the one where we used YLogs, right, to add constraints. So the pattern would be we prepare some data, then we create a profile from this data, like, so we prepare data and then feed this into our ML model, right? And here we want to add monitoring. What we do is we take the data we prepared, pre-processed, and we create a profile, and then we run some checks on top of this. What we can also do to use it in YLabs, we take this profile that we created in the previous step with YLogs, and we just send it to YLabs, right? And then that's all we need to do, right? So we just need to configure like what kind of project we use, and we can start sending profiles. And then out of the box, we will have all the alerts you showed us, right? We don't need to do anything else.
Yeah, I think a big part of it is that before, when we were kind of manually doing all these things, it's a little bit of work of setting it all up. And then also, a lot of times you're going to want to save these profiles and look at them over time, kind of see the drift. Like if you're doing the trailing window between 7 days or 28 days or something like that, you'd be writing those profiles somewhere. So then you have to manage them and then also manage, right, like setting up alerts for it and stuff. So we saw like how much less code it is to really just quickly send these profiles to YLabs, and then kind of handles all of that for you over time.
Makes sense. Okay. Is it time to ask questions, or you want to show something
no, yeah,
else?
I think questions is really is good because I know we're almost out of time. Just real quick, if you are following along in the notebook, there's this other code cell about monitoring machine learning models and outputs. I went ahead and ran it. All we're doing here is basically that same for loop that we did for logging previously to YLabs, except for we're doing a prediction on each of those data frames and then logging those predictions. And we're also saving it in a data frame with the column output in there. Automatically, if you have a data frame with a column output or some variation of like prediction output, some variation of a word containing a string containing the word output, it'll automatically be logged to man, sorry, my Zoom thing got in the way again. It'll be automatically logged over to outputs here. Refresh, and then it's the same thing. So like if you're monitoring model performance over time or model predictions over time, same thing where you can set up alerts based on drift of like model outputs as well.
Okay, so this is where we write predictions, right? Or
correct. So that's like that's like predictions without the ground truth, right? So like a lot of times you're just looking at model predictions, and that can tell you a lot, because again, if you're using a trailing window like we were using for the data inputs, if your predictions are always like, you know, you could log multiple things to it, but if your predictions are always let's say you were logging like a probability or something like that, and it was like always in the 80s, and then all of a sudden it drops way down to 60 something or whatever, that would be a big shift of like how confident your model was on the data, and then maybe you want to go back and see, did something change in your data.
And there was a question, but it's removed, so I don't know if I should ask it or not.
Maybe we answered it.
Maybe I think the question was about Kolmogorov-Smirnov test, and why should we use YLogs if we already can use something like SciPy or something that implements this test. And I think the reason is profiles, right? Because you can create these profiles that are quite handy.
Yeah, I think the profiles is super handy, and like we're seeing people adopt it in industries where like how lightweight they are. One, if you want to move them around and merge them together, it's really easy. And then two, if you're in an industry where you can't really move raw data out, but you can move these profiles out and do drift analysis on them.
So it could be something like healthcare, right? Where you cannot just take patient data and move it to your AWS cloud, right?
Yeah. So healthcare and finance are often two industries that come up. I'm sorry, what was the other one?
Insurance?
Oh yeah, insurance would probably be one as well. Anything where like HIPAA type stuff is involved, or just really sensitive industries where they typically don't like moving around and monitoring on raw data.
And there was a question also about Evidently. So how does YLogs and YLabs compare with Evidently and other tools?
I think one of the biggest things is the again, profiles. A lot of stuff might come down to the profiling of data, where we have these statistical profiles, and then we're basically measuring all the drift and data quality on those profiles. So again, you're not really sending any raw data anywhere. They're incredibly efficient, and there's a lot of features packed into it, which is nice. And then another great feature, and not saying other people don't have this either, but it's just the ease of use of setting it up. Like when you see how easy it is just in the notebook portion of like integrating it into one part of your pipeline, especially when we're just sending to YLabs, there's barely any code here. And we've had, I think a lot of people will be like, oh, we had our intern came in and set this up in like minutes or something like that. And that was really good feedback, that how easy it is to use.
Okay. I don't see any other questions. Maybe something will pop up right now. But do you want to, I don't know, mention something before we wrap up?
I just want to say congratulations to everyone who stuck around. There's still quite a few of you, so I'm glad that I wasn't incredibly boring. I hope you had fun, and I hope you learned something new. Let me know in the chat if you did. Did you learn anything new here, or do you think YLogs and YLabs is interesting?
I want to make a poll.
Oh, gotcha. I forgot that's how we ask questions now, polls.
I closed it, I think. No.
Watch everyone just be like, no, that wasn't fun. But you're still here after an hour and a half, so something must have been pretty good.
Okay, I run a poll. I hope nobody answers no. Maybe I shouldn't not have asked that.
No, it's cool. But yeah, if anyone enjoyed it or found this interesting, please let me know in the chat. And I'd love to do more workshops in the future of, using different types of data sets, talking about using this in different types of pipelines. But again, want to say thanks for everyone for sticking around, and applause for everyone, especially if you went through and you actually ran all the code in the notebook and even set up YLabs in your own. If you never did monitoring before, you've done quite a bit. Some people might have never even trained a machine learning model before, so you might have even just trained your first machine learning model. And if you connect with me on LinkedIn, I'll totally endorse you for machine learning because I knew you did it, And then obviously the most important thing is to keep learning. So if this was new to you, I know we went through quite a bit very fast, and I always like learning by doing. So, some challenges, like you could go adjust the constraints that we wrote in YLogs, try everything with a new data set, use YLogs in an application. It could just be a hobby application, and then connect those profiles to YLabs. Yeah, I think I forgot to link these, but they're all linked in the previous part of the notebook where, they're linking out to basically just the YLabs blog and the YLogs GitHub. There's a really good example folder in there. So if you're looking to get started a little bit more with YLogs, you can go into probably Python, probably what you're using, but we do support Java as well. And you can go to examples, and then we have basics and advanced and integrations in here as well.
And
someone said way cool.
Sorry?
Oh, someone said they had fun or said it was way cool.
Okay. No, I'm going to end the poll before anyone says no, so I don't.
It's 100% yes. Awesome.
Yeah,
again, thank you for everyone for coming. And I know we're a little over time, and I know I have to go pretty soon to something, and I'm sure you have other stuff to do as well. So I'm good wrapping up if you are. But definitely check out the YLogs GitHub. Give us a star. Connect with us in the Slack channel. You can connect with me on LinkedIn, and let me know if you have any other questions.
Okay, thanks a lot. That was fun.